Welcome to Model 9, Unsupervised Machine Learning Hierarchical Cluster. In this model, we will present a case study about how to clustering data based on remaining useful life of the fans from the heat exchanger. Usual, as in the previous model, we have a glossary with the main concept that we have in artificial intelligence applied to maintenance 4.0. So here I present the concept of artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, supervised machine learning classification, and supervised machine learning regression. Artificial intelligence, as we already described, have different applications. In this model, we focus on machine learning, and to be more specific, we are going through one method of unsupervised machine learning called hierarchical cluster. As we already discussed before, the usual machine learning concept is to, since you have one data set, you split your data set in 73% or 8-20%. So you've got the training data, that's 8%. You use this training data for training your model, you pre-select your model, then after you get the result, you test the data in the model and check which are the errors. If it's acceptable, you use a new data set, the similar context that you have before, and then if the data errors are acceptable, we validate this model. However, when you are concerning unsupervised machine learning, as I already explained, we do not split our data set, we use the whole data set to the clustering model. So based on the cluster, we verify the result. If it's acceptable, we can use new data set similar on the previous one, the same context to apply in this cluster model. And then we can validate this cluster model to use a different new data set for the same data that has the same features. So far, we have been describing the different unsupervised machine learning, such as principal component analysis, multidimensional scaling, k-means, Gaussian mixture, and now in this model we are discussing about hierarchical clustering. In the end, we will see in our case that hierarchical cluster will give the similar results that we are able to clustering data based on their features, such as degradation, progression signature, and remaining useful life. So in this picture, you can see this group of heat exchanger are the ones that have the highest degradation between 8 and 100% almost, and the lowest remaining useful life that's lower than 3 months. Then you can see another clustering here, another cluster here, and another cluster here. And that helps the maintenance team to decide the group of equipment they are focused firstly based on the degradation and remaining useful life, and they can organize and plan their maintenance for and focus on different groups of equipment as described in this picture here. But what's hierarchical clusters methods means? Which are the main concepts? So basically, hierarchical cluster methods aims to cluster the data set by defining pairwise distance between the points. And based on such distance, they start to group the data from different clusters, basically the data that are closest to one each other. So in this picture, we can see different points. The points starting to compare the distance between one each other. Then based on the smallest distance, they start to be grouped in clusters in different levels. So the main advantage of this methodology is that we can look from the top-down vision the number of different clusters that we can have, so and in different levels. So for example, if we have only one cluster, if you want to have two clusters, for example, in this data set, they will encompass all this data here. that is below this association. There's a tree here in this cluster, and the others classify here. If you want three clusters, so you consider this data cluster in here and another cluster below this level that will be this data here that is below this level of association here, and the other cluster that encompasses the data below this level that are this group here. And then you can go deeper and deeper. That is very high advantage for maintenance, because under the maintenance context, what we need to do is to group different equipments in different maintenance plan, and despite of shut down the plants many times, find the best time to shut down one specific equipment, what we're trying to do is to group equipment that have similar remain useful life or expect time to failure together. So by the hierarchical cluster, I can make different shutdowns and group and consider three groups of equipment, such as this last case that I discussed. So one group would be this equipment that's defined for this data here, that's on this cluster. The second one would be this data here that is are encompassing for this cluster, and the third one is this one. So that's a very good picture that the maintenance team can have from the equipment, and they can plan their maintenance based on this dendrogram, as we call here. So hierarchical cluster is implemented also based on algorithm. So basically we have three steps. First one, choose the method to calculate the minimum distance between the points. So we'll see later on that there are different methods to calculate such different distance, but since you have the choose the method, you're going to successively merge the closest clusters and put them together, and then you in the end create this dendrogram, as I mentioned before, this picture here that you can see different level of clusters. So in this methodology you can have how many clusters you want, and you can see all levels. It's very good pictures for apply for maintenance. So there are different methods applied to calculate the distance between the points, as I mentioned before. So here we demonstrate some of methods. So we have the single linkage that account the minimum distance between the points. So so you compare different points, then you consider the minimum distance between the points. You have complete linkage that account the maximum distance between the points. That's the opposite. You have mean distance that account the average distance between the points. Then you aggregate the point based the average distance. And you have the centroid that account the distance between the cluster centroids represented by this equation here. So depends on what is implemented in the algorithm. So based on our concept, we are implement the first one, the single linkage, that's taking into account the minimal distance. So the software will start to group the data and will display your algorithm, will display the dendrogram, and then you can have a very good picture of how your maintenance are organized. So let's consider now an example. As I explained in the beginning, we consider that we have a heat exchanger, and for this each heat exchanger we have different fans. So each heat exchanger, they have two lines, and there are two fans in each heat exchanger. That's why we have two numbers here. So the one means the number, the heat exchanger number one, and the fan number one, and here the fan number two. So in case of maintenance, we can also face a situation that in one heat exchanger, one fan is more degraded than the other. So it makes sense to perform some preventive maintenance in one fan and let the second one run for more period of time. So that's all depends the line. If there is a vibration that influence on this in this fan bearing, for example, and that is the case that we are considering here, the fan bearing, and we have the degradation progression and the remain useful life here for different ones. And then the main objective now is to have an idea which are the group of the fans bearing that the maintenance team will working first when we have these different types of degradation progression and remaining useful life. And their idea to apply the cluster is to organize the data, and then we can see which are the data that are organized by themselves. So by applying this methodology, the clustering based on hierarchical cluster, as I already demonstrated, we will have 1, 2, 3, and 4 clusters. So there are 4 groups of fans from heat exchanger bearings that we are putting together. You see that we organize our preventive maintenance, these 2 groups. So this one is the most critical one. So we can even have 2 other clusters here. Consider these 4 first and these 2 after. Despite they have different level of degradation, they have the same remaining useful life. So you can put all in one group, but definitely those one are the ones that have the lowest remain useful life. And then of course, if you put this all, consider that as the first clustering here, you need to pay attention that's the boundary for the first cluster that is below 2 months and the second cluster that there are between 2. There are some clusters that are already in 2, so you can even consider, but they have lower degradation. So even though you can consider all this cluster here, if you want only, if your main information that's the maintenance expert want to consider is the remaining useful life, you can consider all this cluster, this data here in one cluster, for example. So that would be the implementation. But of course, if you put a bigger cluster, you have more equipment. So you also, for maintenance expert, they can have a smaller cluster, but they need to be aware that soon after they finish the service, they need to come to these 2 fans here that there are have a lower degradation progression, but are the same level of remaining useful life, a little bit higher than 2 months. And then they go to the other heat exchanger from this cluster here. Then they move to the third cluster, and then they move to the 4th cluster. And of course, along the time, this cluster will coming down on time. So we need also to consider that, and it's very important in the end that the maintenance expert have such information updated automatically, and that is all about maintenance asset management 4.0 that is supported by artificial intelligence. So in order to implement that in MATLAB software, we need to, as the previous case, just to set a set of commands in the software. So the first one, we need to read our file. The second one, we need to format the file. The third one, we select the method that calculates the pair distance. Then we can plot our dendrogram. We can group and define the clusters. We can define our here our pair distance points, and then in the end we can plot. We'll plot our cluster based on hierarchical cluster methodology. So let's take a look and see how does it works by using the MATLAB. So now we implement the code in a MATLAB. So the first step is to import the file that we want to work. So we need to check the file in where we organize in our computer. So that is the file that we want to work, the file called fan. So then the MATLAB, you go to the first step is to read the template. So here we are, we have we organize the template here. That is the template that we have with 25 fans bearing from fans that we want to organize and see which are the most critical. So now we import our templates, and now we are just read this matrix that we are putting here. Okay. Now the second command is just to format the template to be sure that I have a proper format to perform my model and to have my cluster. My third step is to calculate the pairwise distance. Since I have the definition of pairwise, the next step is to plot my dendrogram. So here we are, you can see the dendrogram for the heat exchanger. Now I can really see which are how the data are organized. So if I want to organize to select based on this diagram, I have the 25 fans bearing in here, defining here. Then if I look to the top down, I see, for example, these three clusters. The first one, they get this number of heat exchanger here that are below this structure here, this tree here. So the second cluster is from this is 7, 8, 9, 10, 11, 12, and 13. That's below this level here. And the third cluster, for example, would be 1, 2, 3, 4, 5, 6. So, and then of course, if I want to organize more number of clusters, I can look on the data and work on it. But of course, I will go further and I will plot the final cluster solution based on hierarchical cluster. So let's check it out and see how does it works. The next command, I will group the cluster, and the next command, I will organize the pair distance, and the final command now I will input set up the graph. Then by input this command, I can see my clustering here. So I define 3 clustering. Actually, this is 1, this is 2, this is 3. But as I mentioned before, the first cluster is too huge. So they basically what is defining this clustering is the remaining useful life that we have in here, that's grouping all this data in the cluster. But based on degradation, I can split this cluster in two and focus in this subcluster. Let's say this would be a subcluster and this would be a second cluster. Okay, so this picture, as I presented in the very beginning, is the final picture, and that gives the direction for the maintenance team to group, to see the cluster for the equipment that have the lowest remaining useful life. And then based in this cluster, they will prioritize from the right to the left the ones that have the highest degradation to start implement some preventive maintenance to avoid that this cluster have a failure, avoid these failures in less than 2 months. And then of course they go to the next cluster here and here that have a higher remain useful life. As I mentioned before, we need to be aware that after 4 months, this 8 will begin 4, this 12 here will begin 8 months, and then the time you constantly being updated. And the main idea is to have such approach in an asset management 4.0 solution that enable that the maintenance expert assess such information. So a very interesting point here is that if you look in this group here, they group in 3 clusters, so we can see which are the 3, the 1, and the 2. So we see that this second cluster here is the one that have more information, so and more data. So that's how they group the cluster. But of course, in the end, I can use, and what is very useful is to use this graph here as the main information to take a decision. They just group in 3 clusters because I select 3 clusters here. But these are the picture that I get the best information. And then based on this information, I can identify the fans that have the gradient bearing and then implement my solution. So what I'm doing now is just to give an example that I can use this command and put maximum cluster as a 4. This is group 1. And if I look in here now, I have the 4 cluster, the 4, 3, 1, and 2. And then if I can and plot my, need to set up the command again to plot a new graph. So let's call that y1, and let's call that now scatters the graph. So I probably have 4 clusters. So actually I've got the same picture. So to have a new graph, so let's just demonstrate again. I have this picture. If I let this GRP, they get data from GRP, so I will have the same graph that I had before. What I need to do is to put grp1 as the command that's set up here. So they give me now the graph with 4 clusters, and we'll see how this data are organized now. So I have 1 cluster here. You can see the first cluster that we have, let's say, remaining useful life below 2 months. I have the second cluster here, only with 2, let's say, 2 fans bearing 2 in the second cluster. Then I have the third and the fourth cluster. So those are the 4 clusters that I have now by implement 4. And then of course I can change this number here for 5 and it's time to implement more and more clusters. So let's get in a conclusion to the hierarchical cluster methods. The advantage is no need to define initial number of cluster as we have a k-means methods. Easy to implement by applying the distance method calculation and an algorithm, and easy result visualization based on the dendrogram. And again, my remark about the dendrogram is that we can see more than one cluster by grouping the different data in the dendrogram, and that's very useful information for maintenance team if they need or want to change the clustering and how they organize the preventive maintenance based on the clustering. Okay, the drawbacks are the result can be high influenced by the distance calculation method, depends upon how the data points are displayed in space. So if you have outsourcing data that is away from most of data where their data are concentrated, that will influence, of course, the clustering. But of course, in the end, we need to look on this data and the usual data analysis, or we take it out this data, or we make a qualitative analysis to see how we consider this data. Is not suitable for a large data set when compared to another methods, and as I mentioned, very sensitive to outlier, this point that's away from most of the points. Okay, so again, the book that you have all these tests about this methodology, you can find it in this book. And thanks for your attention. If you have some question, just send to me, and let's move to the next model.